Welcome to today's class. We'll be starting with the quotient rule. We've discussed already the rules of differentiation, where we talked about the first rule, we talked about the chain rule, we've talked about the product rule, and today we'll be talking about the quotient rule. From the word quotient, or from the word quota, we know that it means division or ratio. We're talking about ratios. So it means that we're looking at divisions. So what it means is that if you're given a function y is equal to, let's call it a particular u over a particular v, and you're asked to find the derivative of this function, then your derivative will be for your dy dx. It will be equal to what? Your v du dx minus your u, the v dx, and all over divided by your v squared. This is a formula for the quotient rule. When you're seeing your value having a quotient division like this, then you use your quotient rule to find the derivative. Now I would like us to start solving questions. Let's give an example. For instance, we're given a question where we have our y is equal to 1 plus 3x over x squared plus 1, and we're asked to find the derivative of our y. How do we solve this? So remember, I told you, first of all, you bring out the values for your u and your v. So our u we know will be what? 1 plus 3x, since our u is the numerator, and our v will be what? X squared plus 1. Then the next thing we have to do is to bring out the values of our derivative for each of them, for the u and for the v. So let's bring that out. We have that our du with respect to dx will be giving us what? When you differentiate u, you have what? Just 3. And then for our dv with respect to dx, when you differentiate it, you have what? 2x. Then the next part will now be to bring it into our formula. So if we have the differentiation of our y, which is our dy prime, I told you that you can use this y prime symbol to show differentiation, that will show dy dx. So we have y prime will be giving us, I want to write this in primes now because I want you to get familiar with how it can appear in different textbooks when you're learning. So for my v, it will still be v. Let me use v. But for my u, it will take a different sign to be u prime, because this is u with respect to dx. It's like saying du dx. Next one will be what? Minus my u, it will still be the same. You have u. Multiplying my v, it will now also change to what? V prime. And everything will be all over what? My v squared. So here is v squared. So solving this, what is my v? My v is x squared plus 1. So I would like to move my screen over to this way. My v is x squared plus 1. So I have this as what? S squared plus 1 brackets. What is my u prime or my du? My du is 3, multiplying 3. Minus u is what? My u is 1 plus 3x. So I have 1 plus 3x. And my v prime is what? My dv is what? 2x. So multiplying 2x. Now I can solve this by opening the brackets. 3 multiplying this will give us what? 3x plus 3 minus 2x opening this bracket will give us 2x plus 6x squared. Now I can solve adding like terms. 3x minus 2x will give us, so arranging this term from their order, that's the order of arrangement. So 6x squared should start up first. Then 3x minus 2x will give me x. And we have here as what? Plus 3. And this is my final value for my dy dx. Let's take another question again. What if we're given our y to be equal to the roots of x over 1 minus 2x raised to the power of 2? How do we solve this? Again, we bring out the values of our u. U will be equal to our root x. Our v will be equal to 1 minus 2x raised to the power of what? 2. Remember, To find the derivative of our v, we'll have to apply chain rule, or you can expand it and solve it normally. But the best would be to apply chain rule. That's why you must get familiar with all these rules so that you can spontaneously apply them without feeling dragged by which formula you to apply it. Then next will be our du. Our du will give us what? Will give us 1 over 2. We've done this many times, so I know that by now you can do this. Remember, our u can be written as what? X power 1 over 2, and we can then find the derivative by subtracting 1 from here and bringing 1 over 2 down here. And then when we convert this back to its non-index form, we'll have it as 1 over 2 root x. So what's about our dv? For our dv, applying our chain rule, I know that my answer will give me what? Minus 4 brackets 1 minus 2x. How did I get this? I got this by remembering I said let my u1 be equal to 1 minus 2x, and let my v1, let's call it v1, let my v1 be equal to u1 raised to the power of 2. Then when I differentiated my v1, when I differentiated it, I had what? 2u1, and when I differentiated my du1, I had it as what? Minus 2. So when I multiplied these two values together, when I multiplied them together, I had it as what? Minus 4u1. And what is my u1? 1 minus 2. So that's why we have this. So when I open this bracket, I have it as minus 4, then minus 4 times minus will give me plus 8x. So rewriting this, I can write it as 8x minus 4, and that is my dv. So bringing it into our equation for solving our quotient rule, our quotient rule tells us that what? The y, the x is equal to v du dx minus u dv dx over v squared. Now the quotient rule almost looks alike like the product rule, only that there is a negative sign here, and then we have divided by v squared. So what is our v? Our v in this case is what? 1 minus 2x raised to the power of 2. So we have 1 minus 2x all raised to the power of 2 minus, what is our u? Sorry, multiplied by our du dx. What is our du dx? Our du dx is what? 1 over 2 root x minus our u now is what? 1 minus, sorry, our u in this case is what? Root x. I think everything here can be quite confusing, so let me take it off so it won't distract our solving. So our u is what? Root x. So we'll put it again as what? Root x multiplying our dv dx. Our dv dx is 8x minus 4. So we have this as 8x minus 4. And everything is all over what? Our v square. Our v square is, for our v, we have 1 minus 2x raised to the power of 2 already. This is our v, then raised to the power of 2 because we have v squared. So solving this, we have for our, let's take our screen over to this side so that we can have more space to solve this. Solving this, we have here as what? 1 minus 2x raised to the power of 2 over 2 root x minus. Now don't be tempted to bring your 2 root x down here, because you must first be able to show that the 2 root x is the LCM of these two before it can come down. So, and it doesn't even need to come down. This one we have to flip up. So we have 1 minus, we have here as what? Root x. Opening these brackets, we have root x. Opening the brackets, we have it as, so let's open the brackets, or let's leave it first as root x. So we have it as root x bracket 8x minus 4 over 1 minus 2x raised to the power of what? 4. 2 times 2 is 4. Then the next thing, I can find the LCM. So if here is over 1, the LCM will give me what? 1 minus 2x raised to the power of 2 minus, here still, we have here as 2 root x, and then here will be what? 2 root x dividing 1 is 2 root x. Multiplying this, we have 2 root x times root x. We'll cancel out the root x and we have it as just 2x. Bracket 8x minus 4. Next, we have here as what? As 1 minus 2x squared, all in brackets, minus, I can open this bracket to be what? To be 16x, we have here 16x squared plus 8x over 2 root x. Now, I know that in this part I escaped writing 1 minus 2x with the power of 4. So let's put it back. And then we have here as what? Still the same thing. 1 minus 2x raised to the power of what? 4. So in this case, I can bring down this 2 with x down to come to this denominator. So we have it as 1 minus 2x raised to the power of 2 minus 16x raised to the power of 2 plus 8x over, here is 2 root x, bracket 1 minus 2x raised to the power of 4. Now, what's the next thing I can find here? I can open up this. You see that here is 8 and here is 16. If I can factorize this, I can actually factorize this. I would have said it from the beginning of this part, but I just noticed I could do it still. So I can factorize 8 out of here. And when I factorize it, I have 1 minus 2x raised to the power of 2 minus, I bring out an 8. So when I bring out my 8, let's bring out a plus 8. Okay, I'll bring out my minus 8. So I can bring out my plus 8. Then here will be giving me what? 8 minus plus 8 divided minus 16x, which will give us what? Will give me minus 2x squared. Okay, so factorizing this, let's go back again. Factorizing this, I know I can bring out what? 8x. So I bring out 8x, and here will be what? Minus 2x without the square, plus here is just 1. So notice something, this value is almost looking like this value, so because we have to factorize them later on. So here is what? 1 minus 2x, which is power 4. So moving on, we have that. Let me rearrange this one to look like this. So my 1 will come over here, and then my minus 2 will come over to the other side. So it will be 1 minus 2x raised to the power of 2 plus 8x bracket what? 1 minus 2x. So here is having my 2 with x. And then we have 2 with x bracket 1 minus 2x raised to the power of 4. So I can factorize this value since they are the same, and then it will be what I have here. When I factor out this, we have 1 minus 2x, since here is carrying the highest common factor of this and this is just 1 minus 2x. Then we have this over what? 1 minus 2x plus 8x over 2 root x bracket 1 minus 2x raised to the power of 4. Then what do we do next? So we have this as equal to, we can solve this, and we can also cancel out 1 minus 2x from here. So cancelling it out, we have that this will cancel out 1 from here, so here's remaining what? 3. So what do we have as our new value? We have 1 minus 2x. Minus 2x can add up with plus 8x, and that will give us what? Plus 6x. So we have 1 minus 6x over 2 root x bracket 1 minus 2x raised to the power of 3. And this is our final answer. So thank you. Let's see if we can take one more question again before we call it for the quotient rule. So let's take one more question. So just to bring back this is actually a plus. Sorry, when we have 1 minus 2x plus 8x will give us plus 6x, not minus 6x. So that's a mistake on my part. Now let's take one more question.